Alrighty, 10.5, angle relationships in circles. Starting off, if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So this angle here is 1/2 of this arc. All right, so I could say that measure of angle A, or not A, 1 is 1/2 measure of arc AB. Okay, this is using inscribed angle rules, right? It's a little bit different than an inscribed angle, but it's still using the same rule. It's an angle whose vertex is on the circle. Example 16. We're supposed to find the measure of angle 1. Well, the measure of angle 1 right there, this angle, would be 170 divided by 2, which would be 85. Next up, we're supposed to find the measure of arc CDE. So that's this CDE. That's that there. We would take the 135, that's its angle. So 135 times 2 is 270 degrees. There we are. Next up, the angles inside of Circle's theorem. And you can copy that text down, but the more important piece is right over here, where we think about the measure of angle 1. It's equal to the other one there, because that's vertical angles. And we think of it, in the way that I remember this, is that it's the average of its arcs. So we add these two together and divide by 2. So whenever we have two, what are these called? These are called chords, right? Yes. Two chords that intersect inside the circle, the angle that they make together is 1/2 of the intercepted arcs. Excuse me, it's the average of the intercepted arcs. Next up, we have angles that are outside the circles, right? So this is inside, and we average them. This one is outside. It's not quite averaging. It's a little bit different. Here we have 3 different scenarios. The first one, we have a tangent and a secant. The second one, we have 2 tangents. And the third one, we have 2 secants. All 3 of them follow the same rule. The angle that is outside the circle is 1/2 the measure of the opposite arc minus the inner arc, right? And it will always be that the angle equals 1/2 the opposite arc minus the inner arc. Let's look at this next one. We have our angle, measure of angle 2 equals 1/2 the opposite arc minus the inner arc, right? The farther away arc minus the inner arc. This one again, we can have our angle there is 1/2 of the opposite arc, the one that's farther away, minus the inner arc. All right, that would be a good thing to write down, to just memorize, to remember. Example 17. Now, this example, it ends up being that this is the center of the circle, and we could say that x equals 74 because it's the center of the circle. But we don't know that always. Because it is not written down, we cannot automatically assume that it is the center of the circle. We have to say, well, x is an angle that is inside the circle, that is not on the center, or we have to use the rule for it not being on the center. We say x is 1/2 its 2 arcs, which are 74 and 74, right? And that's the average. You add them up and divide by 2, that's an average. So x equals 74 degrees, and that ends up being a center. Next up, x is an angle that is outside the arc, or outside the circle. We say x equals 1/2 the farther away, 266, minus the closer, 94. And what did I get whenever I did this the other day? This should end up being 86. Next up, a circumscribed angle is an angle whose sides are tangents to a circle. All right, so this is a circumscribed angle. You'll notice this is also a very similar picture to this one right there. 1017, the circumscribed angle theorem. And I'm going to go over to look at the formula here. We have that angle is equal to 180 minus this angle. All right, neat factoid there. Example 18. Well, there's different ways that I could go about doing this. If you don't remember the theorem there, then you could list all the arcs down and do it that way. But you could just use this theorem that we just learned. We could say, well, x would be 180 minus 127, which should give us 53. Next up, example 19. Well, I'm going to introduce this angle in there. It's going to meet at points D and point C. I can find that the measure of angle A is 180 minus 52 degrees, using that theorem above. So that gives me that measure of angle A would be, what would that be? 128? Yeah, 128. Which means that this arc there is 128, and then angle X would be 1/2 of that arc. So X would be plain old 64. All right, that is all. This was 10.5. Make sure that we have, where's the picture? This is probably the most important picture for it. Alrighty.